Now method of elimination. As I told you, here we will be eliminating one of the variables. Let us do it. For elimination in maths means subtraction. I can see that the coefficient of x in the first equation is 5 and that of x in the second equation is 3. So if I subtract the second equation from the first, let us see if I subtract what happens. If I subtract like this, I'll get 2x minus 2y minus 5y plus 3y equal to 14 minus 120, that is equal to minus 106. I am still left with x and y and I cannot solve it further because I have again equation in two variables. Now what to do? So in order to eliminate, I must make the coefficients equal. For that, I have to take the LCM of 5 and 3, that is the common multiple of the coefficients 5 and 3. LCM of 5 and 3 is equal to 15. So if I convert 5x to 15x and 3x to 15x, I will be able to eliminate them. So what would I do? I'll multiply the first equation by 3 and second by 5. So multiplying the first equation by 3 throughout, I'll get 15x minus 6y is equal to 42, and the second equation is 15x minus 25y is equal to 600. Let this be my equation 3 and this be equation 4. Now if I subtract equation 3 and equation 4, let us see what do we get. 15x minus 15x will be 0 and hence x is eliminated. Minus 6y minus 25y, this will become plus. So this becomes 19y equal to 42 minus 600. What will be 42 minus 600? I'll get an answer in negative. So it will be minus 500 and how much? 500 and it would be 58. Minus 558, whereby y will be equal to minus 558 upon 19. So minus 558 upon 19 will give you minus 29.36. Now substituting this value of y in any one of the equations, suppose I substitute it in the first equation, I'll get the value of y. So I'll get the value of x. After substituting the value of y, the 2 into 29.36, that will be minus 58.72 is equal to 14, and 5x plus 58.72 is equal to 14, and 5x is equal to 14 minus 58.72. X is equal to 14 minus 58.72. 5x is equal to, so this will become minus, if it is 58.72, 5x plus 58.72 is equal to 14, then 14, next step it will be 14 minus 58.72, that will become minus of 44.7. So x will be minus 44.7 divided by 5 equal to minus 8.94. So hence we use, this is the elimination method. where we eliminate one of the variables by making the coefficients equal, and then we resort to either addition or subtraction. One important point, if the variables with equal coefficients have same sign, we will subtract. If they have different sign, addition helps. Now coming to the next slide, the next method for solving a pair of linear equation in two variables is cross multiplication method. Now let us see how does this work for a set of linear equation in two variables. Given two linear equations or a set of linear equation in two variables, we need to cross multiply the coefficients and look at the order in which they are cross multiplied. B1 is multiplied by C2 and B2 multiplied by C1. So we have the formula x upon B1 C2. So just look at this pattern, x upon B1 into C2. So when we are finding the value of x, we are ignoring the coefficient of x in the denominator and only taking the coefficients of y and the constant term. So B1 into C2 minus B2 into C1 will be the denominator of x. Next, when we are finding y, we will ignore the coefficient of y in the denominator and cross multiply the remaining two real numbers. So in which order are we moving? C1 into A2, again C1 into A2 minus A2 into C1, C1 into A2. So in the same way, C1 into A2 and A1 into C2. Similarly, when we are finding the z is not a variable here, so in place of z, we'll write 1 because the coefficient of C1, which is a real number, it's 1. So in place of the constant term in the numerator, I'll write 1 and again multiplying in the same way, A1 into B2 from the top to bottom first and then from the bottom to top. So please remember this pattern, top to bottom and then bottom to top. After simplifying, how do we find the value of x? X upon B1 C2 minus B2 C1 is also equal to 1 upon A1 B2 minus A2 B1. So by cross multiplying, we will get the value of x. Similarly, in the same way, I will get the value of y. Let us try to understand this with the help of a question. Writing down the values of A1, A2, B1, B2, C1, C2. We have this pattern. Now x upon 310. How did we get 310? Minus 2 into minus 120 is 240. 240 minus 70 will give you 310. Just look at the pattern. How did I multiply? X upon, we'll ignore the coefficient of x, minus 2 into 120. So x upon minus 2 into 120 is 240 minus 14 into 5 is minus 70. So this becomes x upon 310. So we get x upon 310 after cross multiplication. Similarly, if I see, how did we get y? Ignoring the coefficient of y in the same way as we multiplied, 5 into 100 from top to bottom, so 14 into 3, y upon 14 into 3 will give you 42 minus 120 into 5. Just look at the pattern here and then here. So, y upon minus 42 plus 600 will give you y upon 558. 1 upon 31. How did we get it? 5 into 5, 25, and 25 minus 6. So, it would be 1 upon, because c is a constant value, write 1 upon. So, 5 into 5, 25 minus 2 into 3, which will give you 1 upon 25 plus 6 equal to 31. So, we got 1 upon 31. Now, we can easily solve for x and y. Let us see how. X upon 310 is equal to 1 upon 31. So, by cross multiplication, x will be 310 upon 31 equal to 10. Y will be 558 upon 31 equal to 18. And we got the solution for x and y. Next, we come to a question of this type where we have variables in the denominator. This is a different question and it can be easily solved using cross multiplication. This is my equation, set of equations where we have x plus 2 and y minus 2 as the denominator, which is quite different from the rest of the questions. Here we will first use substitution, but not that substitution. Since we have common denominators in both the equation, I will take 1 upon x plus 2 as one variable and 1 upon y minus 2 is another variable. Suppose 1 upon x plus 2 is equal to u and 1 upon y minus 2 is equal to v. Now, rewriting the equation, I will get 21u plus v is equal to 4 and 14u plus v is equal to 3. So, we have two equations, 21u plus v equal to 4 and 14u plus v is equal to 3. Now, this can be solved either by substitution, elimination or cross multiplication, and finally, we will get the value of u and v. I am solving it by elimination because elimination becomes easier here because both the variables we have the same coefficient. Subtracting one from the other, I get 7u equal to 1 and u equal to 1 upon 7. Now, I know v was originally, what was v originally? V was originally, after getting the value of u, I get the value of v as 1 first. I got u equal to 1 upon 7 and substituting the value of u as 1 upon 7 in the second equation, I got the value of v. Now, what was this v originally? This v was originally 1 upon y minus 2 and u was 1 upon x plus 2. So, putting 1 upon x plus 2 as 1 upon 7 and 1 upon y minus 2 as 1, let us see what values of x and y I get. I get x equal to 5 and y equal to 3. So, whenever you get a question where in the form of the denominator you have variables and we have common denominators in both, then we can substitute the denominators or the expression containing x and y as u and v. Let us verify. Verification is another important part of solving linear equation. You may be asked to check your answer. So, substituting the value of x and y, I get the left hand side and the right hand side equal for equation 1 and also for equation 2. If I substitute the value of x and y, I get the left hand side equal to the right hand.